1 second. One second, let's start the. So in the last session, that is the demo part 1, we discussed about the importance of Git, Maven, Jenkins. You know what is Git, what is Maven, and Jenkins, that is a CI/CD tool, continuous integration, delivery, and deployment, right? And how we automate the build and deployment process. So this is what we discussed quickly. So this is your Git, correct? Say this is Flipkart. That's a project we discussed about. Flipkart has 100 developers, correct? Say 100 developers. As we discussed in the last class, all these developers connect to Git, correct? They write the code in their local laptops or desktops, and then they all push that code to Git server. This is your Git. Git is the place where we store complete application code. So here we have applications code. We call that as a source code, correct? Source code means whatever we directly write. That means developers. So for example, if you go to, Flipkart project, developers write a lot of Java files. That means you see lot of Java code. There may be some HTML files, there may be some CSS files, JavaScript code, right? Maybe some images and so on. So who writes this code? It's a developer's job. So every day, these developers write the code. Every day, these developers push their code to Git. And see, once developer develops the code, writes the code, then comes a tester, right? Tester has to test that particular code. In order for tester to test that code, somebody has to clone the code, correct? This is your clone, first step. So once we clone the code, what do we get? We get everything here. This is DevOps engineer, DevOps engineer laptop, say for example. So here you'll get .java files, HTML, CSS, some JavaScript images and so on. So once we clone the code, what do? We compile the code, right? Using a tool called Maven, right? Anybody did not take yesterday's demo and then join directly today? Anybody? Anybody missed yesterday's demonstration and then that is part 1 and then join today? If anybody joined today directly, you may not understand something because we discussed a few things in the last session. So go through that previous recording and then take this recording also if you missed yesterday's class. Okay. So as a DevOps engineer, we clone the code, we compile the code. So for example, here 10,000 Java files, we on Java files, right? We compile Dodge. Am I audible now?
Yeah.
There was some network issue from my side, I guess.
RBI ಹೇಳ್ತಾರೆ ನಿಮ್ಮ ಪಿನ್ OTP CVV ಅಥವಾ ಇಂಟರ್ನೆಟ್ ಬ್ಯಾಂಕಿಂಗ್ ಪಾಸ್ವರ್ಡ್
Can you get the control?
ಬ್ಯಾಂಕಿಂಗ್ ತ್ವರಿತವಾಗಿ ಕಂಪ್ಯೂಟರ್ ಮೊಬೈಲ್ ಅಥವಾ ಸೆಕ್ಯೂರ್ ನೆಟ್ವರ್ಕ್ ನಲ್ಲಿ ಇದನ್ನು ತಿಂಗಳ ಚಾಂಪಿಯನ್ಶಿಪ್ ಇಂದ ಜಾಗರೂಕರಾಗಿರಿ ಜಾಗರೂಕರಾಗಿರಿ.
Okay. So this is Flipkart, right? Flipkart has 100 developers every day for fixing the bugs and then developing the new features. They submit the code to Git. And as a DevOps engineer, we clone the code, we compile the code. Why we have to compile the code? Can somebody tell me?
Because computers cannot understand the code which you have written. It should be a executable code, or it can be called as binary code as well.
Correct. So whatever code we write, right, machines don't understand. So you cannot execute that code, right? So somebody has to compile the code, and then the compiler generates the byte code, or you call it as a binary code. So if you write, say, login.java, it will create login.class file. Class file is binary. Okay. Since you have the binary, you can execute the code and then get the results. The reason we have to compile the source code, that is .java file. And Maven is the tool using which we can automate that code compilation process, correct? So you just give all these 10,000 .java files to Maven. Maven can compile all of them and then generates 10,000 class file for us, that is binary. And in order to run the application, apart from this particular Java code, we also need some HTML, CSS code and things like that. So we separate all the resources. That means files which are required for application to run. We call this process as build process. We build applications. We build binaries from the source code, correct? Source code. So that is the first step. So once we have everything, all the binaries in this particular folder, we compress it and we compress it and then we create something called var file. Var is nothing but a zip file. So once we create the zip file, right, that is var, then we copy that var file to a server. So this is your Tomcat server, right? See, any web application you take that works based on client server model, correct? So for example, how do you access flipkart.com? You open the browser, right? Here you type say www.flipkart.com. That's how you access flipkart.com, right? So this browser is called as a client. Browser is called as client. And here you are giving the server URL. Somewhere in say Flipkart office, for example, there is a server, there is a mission with name flipkart.com. So this is your server, okay? Server. So the moment you type flipkart.com, client connects to the server using its name, correct? This is the name of the server, right? Client connects to the server. Server will have the code. Server executes the code and then sends HTML as a response back to the browser. Browser executes that HTML and then you will see Flipkart application login button and things like that. So it's a client server model. And what server we use mostly? There are a lot of other servers but there are a lot of other servers, but Tomcat is very popular and then open source. So mostly we use Tomcat. So the name of the server is Tomcat. So it's a client server model. Client sends a request, server processes the request and then sends a response back to the browser. So here we should have some server, that is Tomcat. And assume that this is your production environment. Name of this server is flipkart.com. Copying this particular var file into this Tomcat server is called as deployment. So we take the code in one mission, we build the binary, that's a main goal, and then we deploy, we copy it to another mission, that is Tomcat server. So once build and deployment is done, then real users type flipkart.com in the browser, they connect to this. And we also discussed about continuous integration, right? So we'll be also having some test environments, right? So here we'll be having Jenkins mission, right? Jenkins will connect to the Git for every 5 minutes. The moment it finds the new code, it will clone the code, it will build the code, it will deploy the code to test environment. So once that is done, then you can run some test cases here. If 100% test cases are successful, you can also deploy the code to production. So we call it as CI. CI means continuously deploying the code to test environment. CD means continuously deploying the code to production. Continuous delivery or deployment. Forget about that for now. So that's about Git, Maven, and then Jenkins. I told you in the last session, there is nothing much great about these three tools: Git, Maven, Jenkins. Very important, but that's kind of, easy automation. Okay. So we have Git, we have Maven, Jenkins, then comes Docker, Kubernetes, then we have Ansible, then we have Terraform, then we have AWS, right? So you know what is Git, Maven, Jenkins. Okay, done. So that's how testers test the application, right? And that's how developers develop the code. That's how DevOps engineers automate the build and deployment process. Okay, so you deployed the code today to the production, and real users are happily, accessing the application without any latency. You're able to serve your Flipkart, application, right, with a good speed, and then everybody is happy. Assume that you have 100 users accessing, and then your application is working perfectly fine. What if suddenly 1,000 users or 10,000 users access your application? Or the point? Assume that it's a big billion day or Amazon Great India sales, right? There are more discounts and then more users, correct? So no matter how many users hit your application, you should be able to serve the application in a stable manner, right? If there is more load, sometimes application will get crashed, or if there is some network issue, or if there is any resource issue, like there is no enough RAM, CPU, hard disk. So because of all this, there is a hardware failures or network failures or more load and things like that. No matter what, we have to run the application in a stable way. How do you do that? Do you think there will be only one machine in Flipkart? No. So this machine has some, say, 16 GB RAM. Ajo, okay, 16 GB RAM, maybe 1 TB hard disk, and then say quad core or octa core processor, 8 core CPU, say for example, 8 core CPU. So this has a limited hardware, right? Limited resources, correct? So probably this RAM, using this much of RAM, CPU, right? You can serve 100 users. What if 1,000 users, try to access the application? Because of less RAM, CPU, right? You cannot, sometimes, you may not be able to, process all users' requests, correct? So for example, you have less resource, right? Less RAM, CPU, 1,000 users are accessing. User enters the credit card details, right? And then what if it will take, half an hour for user to get the confirmation of the order? User entered everything, credit card, OTP and everything. And your application says, please wait while we confirm the order. That means what your application is very slow, correct? See, we cannot give such a bad experience to the users, right? So to avoid these kind of things, right? Usually what we do, if you go to any production, usually we'll be having multiple servers, not just one. That means if one server goes down, you will still have other servers up and running. Okay. So let me just delete it. So the actual challenges come after the deployment. Okay. So if you go to Flipkart, right, production, you will see maybe, around say 100 servers. How many servers? 100 servers. And then here there will be something called load balancer. Name of this load balancer is flipkart.com. Okay. That means we'll be deploying this particular var file into 100 servers. This is the var file, okay, code. So you have 100 servers now. How this works, say for example, 100 users access application using flipkart.com. All 100 users request come to the load balancer first. What is this load balancer here? Very simple. Assume this way. It's a separate mission, say for example, a server. Okay. Here, there is a software running called load balancing software, or that load balancing software. What is the job of this software? If 100 users connect to, right, if 100 requests, if it gets 100 requests, what it will do? It balances the load. That means it distributes different user requests to different machines. Think this guy is a manager. These guys are team members. Manager gets all the work, the complete work. So what this manager will do? This guy will distribute different work to different team member. So load balancer distributes different requests to different machines. So you have 100 members working on something. You have 100 servers, right? Serving your users. How many servers you have? 100 servers. Something is wrong here. 1 second. One second, this whiteboard is locked. I'm unable to write here. Let me close it and then open again. Okay. So when 100 users want to access the application, they type the URL in the browser, right? And all users requests come to the load balancer. What this load balancer will do? It distributes different users requests to different servers. So you have 100 servers processing 100 users requests. Understand this? And here you have the code, right? Tomcat server 1, Tomcat server 2, 3, 4, and so on. For example, for some reason, if Tomcat server 1 goes down, you still have other missions to, serve your application, right? So we call that as a high availability. High availability means if one goes down, you still have other servers to take care of the things, correct? High availability. So you'll be having multiple servers for high availability and then for balancing the load. Oh, done. Say for example, Flipkart is planning for Big Billion Day. What's that? Flipkart is planning for Big Billion Day. Assume that. See, I'm going to explain the, explain a very practical use case. So once you understand the use case, once you understand the problem, then we'll see how Ansible, Cloud, Terraform solves that issue. Okay. So for example, in regular business hours, Flipkart receives 100 orders per minute. How many orders per minute? 100 orders per minute. That means in a minute, they dispatch, Flipkart confirms 100 orders in a minute. So we call it the OPM, orders per minute. So that's a regular business. Okay. Now Flipkart is planning for Big Billion Day. They expect more orders because of the huge discounts. So a lot of people come and then purchase, right? So during Big Billion Day, how many orders they are expecting? 200 orders per minute. For a simple math, assume that 100 servers are required for processing 100 orders. Remember this, just for a simple math, okay? How many servers are required for processing 100 orders? 100 machines. 100 machines for 100 orders. For processing 200, orders per minute, how many machines you should have? Because say 100 orders, yeah, correct. So for 200 orders means more load on your machine, right? So you need to scale up your infrastructure. That means you need 100 more servers. So what Flipkart team does, probably 1 week, 2 weeks before Big Billion Day, they go and then add 100 more servers under this load balance. That means this manager has 200 machines now to do some work, correct? So Flipkart team is very happy, right? So they are like, basically, they think that they are well prepared for Big Billion Day. Okay. So that means what they do, right? They take a mission, right? They install Tomcat here, JDK, maybe, a lot of other softwares, and then they deploy the war failure. See, assume that a request comes to the load balancer, right? It gives the load balancer, it gives that request to this mission. So here you should have the code, correct? This code. So Tomcat server is running here, that will execute the code and then sends response back to the browser. So you need to have all those, set up in all 100 machines. So it will take, say, 1 week for Flipkart team to build these servers. Okay. Now, Big Billion Day is on. Big Billion Day is on. They started receiving 100 orders per minute. They started receiving 200 orders per minute. Is there any guarantee that they won't receive 300 orders per minute? Possible, right? Now, they started receiving 300 orders per minute. The moment, they receive 300 orders per minute, because you have less resources, less servers, what happens? Your application may get crashed, or you'll end up in serving the application very slow. Like I said, once users are entering the credit card and then they have to wait for half an hour. You cannot wait for the half an hour, right? So you cannot give such a bad experience to your users. See, if this happens, what will happen? Tell me. Eventually, your business will, go down, and then you may have to shut down your company. Correct. See the problem now, and it will impact on the business big time. You cannot, it's a credibility issue, right? So see the problems that you face, right? So the question comes, how do you solve this problem? Even you have 100 more servers, for example, what if you get 400 orders per minute? What if you get 500 orders per minute? You cannot predict sometimes, correct? You cannot predict the business. So they started receiving 300 orders per minute, and as a result, what happens? Flipkart is crashed. So the question comes, how do you solve this problem? adding more and more missions is called as scaling up the infrastructure. Infrastructure scale up, scale up, scale down. Scale down means remove the extra servers that you added, and then you are back to the normal traffic. Scale up, scale down. That's where we think about Ansible. Ansible can solve this problem. Ansible is called as configuration management tool. What do you call Ansible? What is it? What is Ansible? It's a configuration management tool. Say for example, in this mission, you need JDK, Tomcat, blah, 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 lot of software tools installations, right? Instead of you manually installing all these things, right? We use Ansible for installing all that stuff. So what was the problem here? When you started receiving 300 orders per minute, you don't have time to go and then prepare 100 more orders, correct? You don't have time, right? Because you have to take a mission, install operating system, install that, this and all the stuff. So you cannot add 100 more missions on the fly dynamically. No, it's very difficult because you are in manual, you are believing in manual job, correct? So that's where we bring Ansible in the picture. If you have Ansible, you know what you can do? I can write here some code. Okay, it's a a declarative code. It's not even like a script. Okay, it's at a very high level, kind of a configuration file in YAML file. We call this a playbook. We call this as playbook. That means it has all the strategy to play your game. Even now, in most of the sports, right, before game starts, or 1-2 days before, they prepare steps, a strategy. We call that as a playbook. How we have to play the game, plan 1, plan 2, and things like that. Same thing here, right? Here, what is this playbook contains? It has the configurations that needs in this mission. So here I'll say I need JDK 11, for example. I need Tomcat. I need blah 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 blah. Whatever is required in these missions, right? You just write all those things at a very high level in Ansible. We call this a playbook code. And then when you want to add more and more missions, what you can do, just take the hardware, 100 missions, and then you just need to apply this playbook, this code on all these 100 missions. So Ansible can go to all 100 missions and then install everything which is required for you within few minutes. Let's see now. So during Big Billion Day, right, the moment we start receiving 300 orders per minute, what do? Right, our automation will automatically apply this Ansible, right, and then it will scale up more and more missions. You're not manually installing anything here. You are dynamically provisioning the server, and then that means creating the server and then installing everything. That means basically you are preparing the mission. Since Ansible helps us to configure all these installations, we call it as configuration management tool. That's about Ansible, right? Let's see where this Terraform and then AWS cloud comes into picture. Say this. Now, if you see here, before Big Billion Day, right, Flipkart has to purchase this hardware, correct? Assume that Flipkart purchased 200 extra missions, 200, RAMs, CPUs, and things like that. Next day, once Big Billion Day is over, do you need these 200 servers? No. Correct? We don't need these 200 servers, right? So what do you do then? Because after Big Billion Day, your traffic falls back to the regular, right? So only 100 orders per minute you receive, right, in regular business hours, business days, and then 100 missions are enough for you. So what do you do with these 200 missions now?
Need to rent the servers from Azure, Microsoft, or AWS.
Correct. So assume that you purchase this hardware on your own. What happens? You have to, probably take some space for rent to keep these 100 servers, 200 servers, correct? You need to buy racks, cables, power bill, AC, right? Again, you need some, human resources, right, to manage these things and stuff like that. If you do this, what happens down the line? Say, for example, after an year, right, your maintenance cost will be double than the purchase cost. Maintenance cost will be double than purchase cost. So it is not a good idea to purchase the hardware on your own in this kind of. That's where we think about some cloud. One second. Okay, so it's not a good idea to purchase the hardware on your own. That's where we think about the cloud. So other than that, there is some cloud, okay? AWS, or it can be Azure, or it can be Google, or whatever. Okay. So cloud says when you need some extra hardware, don't purchase on your own. Instead, just look up the cloud, take the little meaning of it. Just look up the cloud and then say, hello cloud, I want 200 missions. And you will get 200 missions instantly from AWS or Azure or Google Cloud. So they maintain huge infrastructure in their data centers. That is their business, correct? They say, we have huge infrastructure, right? In fact, a lot of other services. They say, when you need some infrastructure, don't purchase on your own. Instead, just come to us, take the infrastructure, right? How much ever you want, and then pay for what you use. That's very important. Pay for what you use. Pay as you go. You want these missions for 24 hours. You just need to pay only for 24 hours. That's all. We call this as infrastructure as a service. What do you call that? IaaS. Infrastructure as a service. This service is called as IaaS, infrastructure as a service. Why? You are taking infrastructure as a service from them and then you are paying for the service, correct? This is the better idea. That's where we think about the cloud. I'll give you a simple analogy, okay, very basic one. You have some function in your family, right? You need some extra chairs, tables, and stuff like that. What do you do? Do you go and then purchase? No, right? If you purchase what level, you may have to have a separate space for maintaining those things, correct? Until next function happens in your family, you don't need that stuff, correct? So what do? We go to some shop and then we take things based on rent and then we pay for what you use 1 day, 2 days, 3 days. Same thing here. So likewise, it's not only the infrastructure. You can take a lot of other things. It's like platform. There is something called platform as a service. You don't need to run the platform. They run the platform and then you just access it. Platform as a service, a lot of services are there. So that's where we think about the cloud. AWS or Azure or Google. Cloud is different skill. Cloud is different skill. DevOps is different skill. Both are not same. But both are complementary technologies. That means if DevOps is there, mostly we use cloud. Okay. So kind of things. So if you want to focus your career only on cloud, say for example, probably you will learn AWS, Azure, Google. That means you learn all the clouds. And then you need to do some certification. There is something, associate solution architects. Associate solution architects. That's their job. They are like pure cloud experts. How much cloud is required for DevOps engineer? Or is cloud required? Mostly, yes. Most of the applications today use some or other cloud. So, for example, if your application is not using cloud, you don't need to learn cloud, not required, right? Assume that your application is running on AWS cloud. That means you have the infrastructure from the AWS. So as a DevOps engineer, you should know how to provision these servers, how to configure the servers, how to deploy the code in the machine, which is in the cloud and things like that. So you need to learn you need to have basic or intermediate level of cloud knowledge. If you have that, it is good. So we call that as AWS DevOps. What's that? AWS DevOps. That means most of your infrastructure and a lot of things are running in AWS. So AWS DevOps. People call it as AWS DevOps. If you have your infrastructure running in Azure, people call it as Azure DevOps, or Google GCP DevOps and so on. So it is just that. Okay. So DevOps is your primary skill. This is the way it is. Okay. DevOps is the primary skill. AWS is kind of secondary. In some interviews, they won't ask you the cloud, a single question on the cloud, because they have their own missions, infrastructure on premise, or they don't have or they're not using cloud. In that case, you don't need to, they won't ask cloud. But if you have DevOps and if you also learn cloud, that will double the chances of getting the job with a better package and in a better company. It is just that. Okay. That's the importance of cloud in DevOps. Okay. So you have, you have taken 200 missions. These are the steps. Okay. During Big Billion Day, when you get 300 orders per minute, suddenly, what do you do? First step is what? You have to take the infrastructure from the cloud. First step. Once you have missions ready, then as a second step, you go and then run this Ansible. Ansible will go to each and every, it'll log into each and every mission, and then it'll install whatever is required in these missions to run the application, and then it'll attach the 100 missions to the load balancer. So first step is provisioning the servers. Second step is configuring them. So Ansible is called as configuration management tool. Again, how do you provision or create 100 missions from the cloud? Is it possible for us to manually go to the cloud, click maybe 5-10 options and then create a mission? Right? It's not possible, right? Again, there is a manual task, right? 100 missions, it will take time for you to create 100 missions. That's where we think about Terraform. What's that? Terraform. Using Terraform, we provision the infrastructure. Using Terraform, we create the infrastructure first. Means, think Terraform as a person, right? Go to Terraform and then say, hello, Terraform. I need a mission. I need 100 missions with 8 GB RAM, with this much of CPU, hard disk, with this network settings, for example, and things like that. Right? So Terraform can talk to any of the cloud. Terraform has the ability to talk to any of the cloud, and then it can, based on your instructions that you have written here, it can provision 100, 200 missions for you very easily. That's the job of Terraform. Terraform is called as infrastructure provisioning tool. What do you call this? Infrastructure provisioning tool. So first step is this. Okay. You first go to Terraform. Say first step, for example. Okay. Using Terraform, since I already wrote one here, I'm writing 0. Okay. First step. So first you go to Terraform, right? Ask Terraform to create 100 missions. And then you have 100 missions here. And then, okay, first step and then second step. Second step is applying the Ansible. Now you see the importance of cloud, right? Ansible, and then Terraform here. Assume now some company is not using, Ansible, Terraform, AWS. What happens? They cannot solve this problem, right? So they'll end up in a lot of problems, correct? So people say DevOps is a philosophy. DevOps is a culture. It's a culture. Means it is up to you whether you adopt this culture or not, whether you adopt this automation or not. It is up to you. If you have this culture, if you have this DevOps automation tools and then automation strategies, then you gain all these benefits. DevOps is not a technology, right? It's a culture. So companies are realize the importance of DevOps, And that's the reason all companies are trying to adopt DevOps as soon as possible because of all these things. That's the reason DevOps is a very niche skill in the market today. DevOps engineers are highly paid resources. Sometimes, or most of the times, DevOps engineers are paid more than the developer, more than the testers, more than any other teams working in a particular project. So, as a DevOps engineer, we will be learning Terraform, Ansible. We also have basic intermediate knowledge of cloud, and then our automation. We automate all these things, scale up and then scale down. And once big blend is over, what do? We'll just destroy these missions and then we fall back to the normal traffic. We call it as a scale down. Scale down, scale up. Or we call it the auto scaling. That means you're not manually scaling up and then scaling down. Okay. Automatically, based on the load, your automation is able to auto scale, perform the auto scale. See the importance of DevOps, right? Understand this? Any questions you have about these three tools? Any questions? Any questions in them?
Before
So where do we apply
Kubernetes, correct? Okay, that's the next thing. So Git, Maven, Jenkins, right? You know what is Ansible, Terraform, AWS, and then next we have Docker.
nice for small question.
Yeah.
Uh,
Please go ahead.
Before proceeding with the DevOps, we need to be learn about the AWS or.
So this is the sequence I follow. We first start with the Linux basics. So here I will first teach you how you can set up a local lab first. That means in your Windows you will be having a Linux machine first. Okay, for practicing all these tools. And then we practice this Git, Maven, Jenkins, Docker, Kubernetes, Git, Maven, Jenkins, Docker on the local Linux machine that we have, that we set up. And when we go to Ansible, Terraform, AWS, right? After completing these tools, then we learn AWS, then Ansible, Terraform. After that, Docker, Kubernetes. So for practicing these two tools, you need to learn AWS. It doesn't matter if you learn AWS at the beginning also, anything is fine. But I usually introduce AWS after these tools. Okay. Let's see what is this Docker Kubernetes. Again, Kubernetes is one of the popular tool that we use in DevOps. Let's first see what is this Docker. Okay. Let me take some use case. For example, some story. Okay. You have your friend. Your friend has a mission. Okay. Your friend has a mission. You have this guy has some RAM, CPU, and then hard disk. And your friend installed some operating system on top of the hardware and then running some application one. This is your friend. He has a mission, right? Assume that this is a physical server. Means your laptop, say, for example, it's a physical server. Running application. Your friend wants to run another application 2. Assume that this guy is working on some startup idea, or wants to run something on a dedicated mission. So what this guy has to do? This guy has to again purchase RAM, CPU, hard disk, install operating system, and then run application 2 here. Correct? That means to run application 2, this guy ideally has to purchase a separate mission. So instead of purchasing a new hardware, right? This guy comes to you. Your friend comes to you. Say, for example, this is you, okay? You also have a mission. You also have a mission. So you run, you have some operating system, and then you're running your application. This is UC, for example. You also have a mission, some RAM, CPU, and then hard disk. You have some operating system. On top of operating system, you are also running some applications, say, for example. So when your friend needs a separate mission, right, he comes to you asking, can I use your mission? This is a physical mission, okay? Physical mission, physical server. Your friend says, I need a separate mission. Can I use your mission? You say, this is my mission. I am also running something. No, I cannot give my mission to you. Go and then purchase a new one. Your friend says, okay, fine, right? Can I ask you a few questions? You say yes. Your friend asks you, how much RAM you have? 8 GB. How much CPU you have? Say, octa-core processor, 8 virtual CPUs, octa-core. How much hard disk you have? 500 GB. Next question comes, are you using 8 GB? Are you using octa-core, no, all processors? Are you using complete 500 GB hard disk? You say, no, I hardly use 2 GB, maybe 2-core processor, maybe 100 GB hard disk. Your friend says, right, anyway, you invested a lot of money to purchase this hardware, and you're not using the hardware efficiently. You are not using hardware to its max capacity, correct? Is it possible for you to share this hardware, unused hardware? So his plan is to take the unused, maybe 4 GB this guy is using. This guy's one plan is to take 4 GB, right? Maybe 4 CPUs, and then maybe say 200 or 250 unused hardware here. And then this guy wants to install operating system and then run this application to here. So your friend is asking, is it possible for you to share the unused hardware? You say, no, there is no way. It is not possible to share the hardware if you are living in the physical, if you're living with physical servers. You take your laptop, right? You must be having maybe 500 GB or 1 TB hard disk, right? Are you using complete hard disk? Are you using octa-core, say 8 GB RAM always? 8 CPUs always? No, right? Other than that, you have a mission, right? This is your office laptop. This is your office laptop. You want to learn DevOps. You need a separate mission. What do? You have to again go and then purchase RAM, CPU, hardware, install operating system. You need to purchase a separate mission, right? Again, because assume that you cannot practice your DevOps in your office laptop. You want a separate laptop. So you have to go and then purchase the hardware. So here you already invested some money. You are not using this hardware. Again, you are purchasing it. Correct? So that is the problem we face with respect to physical servers. So you cannot share the hardware, right? You are unable to use the hardware efficiently. That's where we think about something called virtualization technology. What's that? Virtualization technology. If you have virtualization technology, you can solve this problem. See, in virtualization technology, this is what we do. Okay. So you have some hardware. This is a demo class. If you don't understand something, okay, you don't need to worry. If you're able to understand, say 60-70% of it, I'm fine with that. Okay. When we discuss these topics, I'll explain things from very basics with simple analogy use cases. So don't worry about that. That's my experience, right? That's the job of any trainer, correct? That's where my 11 years of teaching experience comes. Anybody, everybody who have great DevOps knowledge cannot teach, right? So teaching is a separate skill, correct? It's not just a technical thing. You have technical knowledge, and then you cannot become all people cannot become the teacher, right? That comes with experience, of course. Anybody can master it. That's where experience matters. So I know how to simplify the things. I know what is required for you to crack the interview. I know what is required for you to survive in real time, right? So based on that, I curated the curriculum, right? If you just follow my guidance, maybe, within 1.5 months, you may, get the, you'll be able to crack you can crack the interview, within 1.5 months after completion of the course, if you follow my guidance. So here you have RAM, CPU, hard disk, and then you have some operating system, and then you have a virtualization technology here, virtualization software. Assume that this is a software, okay? Virtualization software. If you have this virtualization software, you know what? You can create multiple missions on top of the same hardware. Mission 1, mission 2, mission 3. So we call it a virtual mission 1, virtual mission 2. Similarly, you can create any number of virtual missions, virtual mission, n number of virtual missions you can create. How this works? We have this software, correct? So what is the job of the software? You have RAM, CPU, hard disk, right? So this virtualization technology supplies same RAM, CPU to all these missions. So that is the job of virtualization technology. Virtualization means which is not physically present, correct? So you don't have physical hardware here. You are able to supply the hardware virtually. And that is the job of this virtualization software. So using this virtualization software, what you do, you supply the hardware, RAM, CPU, hard disk to this mission, right? And then install operating system on top of it in each and every mission. And then your mission is ready. So when your friend comes to you for a new mission, if you have the virtualization technology, what can you do? What you can do? You just, if you have this virtualization software running, right? You can just create a mission and then you can, your friend can run a separate application here, right? Correct. And you see, you're not purchasing the hardware, correct? You're not purchasing the hardware. You are able to, you're not purchasing the hardware. You are able to create the separate mission. You're able to create a separate mission with separate hardware using this virtualization technology. That is the advantage of virtualization technology. And using virtualization technology, you can efficiently use the hardware. I'm seeing this problem only today. Usually this doesn't happen. Again, it is locked. Whiteboard is locked. What is this symbol? Okay, so if you have this virtualization technology, right, you can create multiple missions on top of the same hardware, and then you can utilize the hardware in efficient way, correct? So virtualization technology is even very popular today. It's popular, it's very popular even today. But these days, people are moving from, or you can say, infrastructure is moving from virtualization to something called containerization. What's that? Virtualization to containerization, or virtualization to Dockerization. What is that? See this. This is your hardware. Here you have some operating system. On top of that, here I'm going to install Docker. Docker is again a tool, or think it is a software. So we call it the containerization tool or containerization software. So you have some operating system. Okay, you have some RAM, CPU, and then hard disk drive. Using Docker technology also, you can create any number of machines on top of the same hardware. Like virtualization technology, using Docker also, you can get multiple machines on top of the same hardware. Docker also virtually distributes same RAM, CPU, hard disk to all these machines, like virtualization technology. When you can create multiple machines using virtualization technology, right? Here the Docker is also doing the same thing, right? So what is the importance of, what is the advantage of Docker? What is the difference between virtualization technology and then Docker or containerization technology? What is the difference? See this, the key differences. Here, if you ever have created a virtual machine, you know this, or leave it. Virtualization technology is supplying the hardware, correct? Okay. And then you have to install operating system in each and every virtual machine. You have to install operating system in each and every machine. And this operating system is like almost 5 GB. If you take Ubuntu, for example, the latest one, it is 5 GB code. It is 5 GB code. So you have to install 5 GB operating system in each and every mission, correct? In other words, you can say that each and every virtual machine contains a 5 GB operating system code running, correct? Operating system is again a software, right? We call it a system software. And what is the size of this software? 5 GB. So by having the 5 GB code running in each and every virtual machine, again, you are wasting a lot of hardware, correct? You're wasting a lot of hardware. Study says 10 to 20% of your hardware is consumed by the operating system. So it is not lightweight. It is little, it comes with little extra cost. That means you're wasting a lot of hardware here. For example, you buy, 64 GB, mobile. Do you get 64 GB? No, right? So maybe, you get only 60. Where is remaining? That goes to the operating system, correct? One. See, by having the operating system, you're wasting a lot of hardware, correct? So that is the problem with virtual machine. So assume that it's a virtual machine, okay? It will take more time to create a mission, correct? It will take more time to create a mission. Why? Because you have to install operating system in each and every mission. So it will take more time to create a new mission. Think those big billion days kind of days, right? Where you have to add more and more missions. If these are all virtual missions, it will take more time for you to create a mission, correct? If you go to Docker, say for example, you know what? Docker virtualizes the hardware as well as operating system also. Docker virtualizes the hardware as well as operating system also. You can think that way. That means you don't need to install, a 5 GB operating system code, right, in each and every mission. No. Remember one more thing. If you are creating a mission, right, using Docker, we call it a container. What do you call that? Container. If you are creating a mission using virtualization technology, we call it a virtual mission. If you are creating a mission using Docker, you call it container. Container 1, container 2, you can create any number of containers using Docker. And what is the advantage? You don't need to install 5 GB of physical operating system code in each and every container, each and every mission. Container means a mission. Virtual machine means a mission. Okay. You can run anything. For example, you can run your application 1 here, application 2, application 3. Here also you can run application 1, application 2, application 3. It's just a mission. So since 5 GB operating system, since the physical, since the operating system is not physically running here, right? You can create the mission very quickly. That means it'll take less time for you to create a new VM, correct? It takes very, less time because you don't need to install operating system, right? You know what? In fact, you create a new mission within less than 1 second. Can you believe it? Within less than a second, you can create a mission because you don't need to install operating system. So it's very fast. Within very less time, you can create a mission if you have Docker. First advantage, right? 1 second. Okay, so that is the difference between virtualization technology and then Docker, that is containerization technology, correct? Second advantage, you can start, it will take more time to start a VM, correct? Say you want to, the moment you switch on the power button, for example, since there is operating system, you have to wait for the operating system to come up, correct? So it will take more time to start a VM. It will take more time to stop a VM because you have the operating system. And the main thing is what? It is heavy. It's a heavy. So that means you're wasting a lot of hardware. If you go to container, since there is no operating system, it will take less time to create a mission. Within, it will take less time to start a container. That means you don't need to wait for the operating system. It will take less time to stop a mission, and it is lightweight. Lightweight. Okay. Why it is lightweight? Say, for example, you have 8 GB RAM, octa-core processor, 500 GB hard disk. Okay, 8 GB RAM. Say, assume that maximum, with this hardware, you can create 3 virtual machines. 3 missions only you can create with this hardware. If you can create 3 virtual machines on this hardware, with the same hardware here, you can create 30 containers. How many containers? 30. Why? It's lightweight, correct? You don't have operating system, physical copy of the operating system in each and every container. So containers are lightweight. On top of less hardware, you can create more and more missions. So that is the reason these days we prefer containers. We run our applications in containers because it's a lightweight. That is the advantage of Docker. Where you can use containers now, these missions, 100 missions or 300 missions, can be physical missions, right? You know the disadvantage of physical mission, right? You cannot share the hardware. Then these 100 missions can be virtual missions also, right? VMs. That means you are using virtualization technology. Virtualization technology is better than physical servers, but again, there is a drawback, right? It takes more time to create a mission, to start the mission, stop the mission, and it is heavy. And these 100 missions can be containers also. So if you are running your application inside a container means a mission, right? Container means a mission. With less cost, less hardware, you can create more and more missions. These are lightweight, and the container creation takes less than a second. That is the reason these days infrastructure or applications or companies are trying to run their applications on containers. So that's kind of very popular approach that we follow today. So how does it matter to the DevOps engineer? It is DevOps engineer who creates the containers and then who runs the application in the containers. It is our responsibility. So if your application is running in containers, as a DevOps engineer, you should know how to create a container, how to deploy, your application in the container, and how to manage the container and stuff like that. So that's the reason we learn Docker. We are kind of experts in implementing this containerization technology. We are experts in Docker. Clear with this Docker? Any questions? Understand the difference between virtualization technology, containerization technology, why companies are preferring containers now. See, world started adopting containers actively, say 7-8 years back. Whereas Google started adopting, started using containers 14-15 years back. If you see today, your Google search, Gmail, Google file system, your Netflix, all these things are running on containers today. If you go to Google data center, right, you see millions, billions of missions, millions of missions, millions. Assume those millions of servers are physical servers. Can they afford to have, physical servers, 1 million or millions of physical servers? No, right? Why? Because physical mission, right? So once you allocate 2 GB to a mission, but no matter whether you use it or not, it is only for that mission, correct? You cannot reuse that hardware, correct? So it's a costly, and it can be, those millions of missions can be virtual missions also. Virtual mission again is heavy, correct? So they are using containers. So Google mail server, kind of large scale enterprise applications today are running on containers. Now world, understood the importance of these containers, and then companies are trying to containerize their application. That means trying to run their applications on containers these days. Again, something went wrong here. It's happening because of the zoom. It's a zooming issue, I guess. It's trying to zoom. Okay. So just give me another 5 minutes. I'm done. Okay. So these missions can be containers, right? Say for example, okay, fine. You are using containers for running your applications. You are using containers for running your application. That means you are running your application inside the containers. Okay. Let's say, what is this Kubernetes? Kubernetes is called as orchestration tool. What is it? Kubernetes is called as orchestration tool. Meaning, assume that you have 100 or 200 containers or 1,000 containers you have. Again, when you have more and more containers, you get into some issues. You get into a lot of challenges in maintaining those 100 containers or 1,000 containers. What are those challenges? First thing called self-healing issue. We need to have self-healing mechanism. Means, assume that I need 100 missions always. How many missions? 100 missions always. Minimum 100 missions I need for my users, for my users. What if 10 containers go down? 10 missions go down? You have 90, and then your application will become slow, correct? Because less people to process the orders, correct? Less missions. So question comes, when 10 goes down, right? How do you bring 10 replacement, how do you bring, another 10 servers automatically? Gone the days where you go, have some monitoring system, right? If 10 servers go down, it will send you an email alert, then you log in, then you create a mission and things like that. No, we don't have time. So what I expect here is what I expect here is, if 10 missions go down, somebody should bring 10 missions automatically for me without any manual intervention. Again, this without any manual intervention, without I doing anything. If 10 goes down, 10 missions should come up automatically. We call that as self-healing feature. Self-healing. When there's a problem in the system is able to identify that there is a problem, and then it will heal, it will fix the problem on its own. self-healing. That's where we think about Kubernetes. In short, we call it as K8S, Kubernetes. Between K and S, you have 8 characters, 8 letters, Kubernetes. If you have Kubernetes, you know what? You can tell Kubernetes, hello Kubernetes, I want 100 servers always, desired state. You tell your desire, okay? Desired state. I want 100 servers always. You can configure Kubernetes in that way. So I go to Kubernetes and then I configure, telling, okay, I want 100 servers. Again, in Kubernetes, we write something called YAML scripts. That's a very a simple one. So Kubernetes know the desired state, right? What you want 100. If 10 goes down, Kubernetes will bring 10 containers automatically for you, having everything ready. See the advantage of Kubernetes. Kubernetes will help you to have this self-healing feature in real time. So since Kubernetes is helping us to manage the containers, we call it as container management tool or orchestration tool. Orchestration tool. Second thing, you would have seen orchestra conductor, right? There's a troupe, right? A lot of musicians are playing musician. One person will be sitting in front of these people, controlling, all these, musicians. Orchestra. This orchestra conductor. What is the job of this guy? This guy has to make sure that, right, all these musicians play something in sync. Kubernetes does the same thing here, right? It will go and then first, bring the database. It'll, you have web servers, you have application servers, blah, blah, and so on. So it'll coordinate everything, and then finally it will run your application in a smooth way. Orchestration tool, orchestra conductor. Or just think that it helps us to manage all these things, self-healing. The second problem that we face is GDR, zero downtime release. Zero downtime release. See, it's not just a concept, okay? As I said, we are going to work on 3 real-time projects, right? Almost 3 to 4 real-time projects. So I'll take some, project. So we'll be taking a project. We'll be literally configuring all these things. Okay, it's not theory. So you take the code, you compile the code, you create the var file, we deploy the var file in a virtual machine, then we deploy the var file in the containers, then we go to Kubernetes, we set up the load balancer. So everything, whatever I'm showing you here, everything you'll be learning in a pure practical way. Okay, so don't worry on that. So where is that? Self-healing. That's an advantage of having Kubernetes. Then we also get another challenge here. That is zero downtime release. Means you are running some code here, right? You have the new code n+1. When you deploy your new code, you should be able to deploy the new code without bringing this environment down, correct? You would have seen this in some websites. When you access a website, they'll say, please come back after 2 hours, 3 hours. We are updating something. We are doing, we are rolling out some new features for you. You cannot do that for Facebook, Flipkart, Insta, right? Because if Facebook, Insta goes down, people cannot even live for 2-3 minutes. A lot of businesses are depending on Insta and then Facebook for leads and a lot of things. So it can't go down. If it goes down frequently, again, it's a credibility issue. People may not like the platform, correct? So when you deploy the new code, right? So you should be able to deploy the new code without bringing the environment down. How do you do it? Of course, you can automate it by writing, shell scripting, by writing some, say Python scripts and things like that. But again, you will end up in writing thousands of lines of code because it's your own automation, right? And there is no guarantee that you'll be able to automate that process, efficiently, correct? So that's where we bring Kubernetes. We count Kubernetes. If you have Kubernetes, you can release the new code to the production without bringing the environment down very easily, without you writing, thousands of lines of automation code, your own automation code. Just tell Kubernetes, hello Kubernetes, this is my new code, please deploy it. It has different strategies. Again, you can select different strategies and then you can deploy. What it will do, for example, it will bring 2 missions down, add 2 missions with new code, again 2 missions down, 2 new missions with new code. So we call it a rolling update. Okay, so it has different ways to release the new code without bringing environment down. If you have Kubernetes, you can do this very easily. 0 downtime release. Rollback, very important, right? You deployed the new code, okay, n+1, okay. Again, this code is not working for some reason, it's not working up to your expectation. We want to take it out and then have the older code, correct? How do you do that? If you have Kubernetes, you can roll back very quickly without you writing much code. Then auto scaling. That means when there is a more load on the system, you should be able to go and then add more and more missions automatically. When there is less load, you should be able to remove the additional servers. Scale up, scale down automatically. Who will do that? If it is Kubernetes, you can tell Kubernetes saying, this is my requirement, right? And if, for example, a CPU or RAM utilization goes beyond 90%, go and then add more and more mission. You can configure all that stuff. So, and Kubernetes works only with containers. Okay, Kubernetes is only for managing containers. If you have virtual machine, then you cannot use Kubernetes. So since it helps us with all these things, we call it as container management tool or orchestration tool. That's the advantage of Kubernetes. That means very simple. If you have Docker, if you have containers, you almost should have Kubernetes. Docker and Kubernetes. Understand the difference between virtualization technology, containers, why we use containers, and why we use Kubernetes. Now you see. Again, it's a DevOps engineer who automates all these things. It's not that you'll get a chance to work on all the tools in all the projects. As I said, yesterday, when you have 10 members team, few people will work on this, few people will work on this, and so on. So maybe a senior member, you have senior member in the team, he or she works on all the tools. That's all. And then you'll be also learning DevSecOps. Okay, DevSecOps. So these are the tools we learn. And Grafana, and then we have Prometheus. So these are the monitoring tools. Okay, so DevSecOps is like kind of 4 or 5 hours concept it is. So what we do in DevSecOps is at a very high level. Okay, since we don't have time, I'm not going into much details. So usually, traditionally, even today, a lot of companies do the security testing at the end. That means a lot of companies, people do the security testing only in production or in test environments. Okay, they don't usually do the security testing, from the beginning stages. So this is DevOps, right? DevOps. What is this doing? It is basically bringing development teams, QA teams, and then operations teams together. Operation teams means you have your network engineers, database administrators, system administrators, application support, production support. So all these teams will be working on the production. So what you're doing, your process, your automation is bringing everybody together, everybody at the same page, right? That means starting from the developer, you're coordinating this, right? Starting from the developer, right? And then here you have the testing. So when developer does something, writes a new code, you come in the middle and then you deploy it and then you connect this development code developer with the QA. Again, you deploy the code. So once you deploy the code, then comes this network engineers, database administrators, application support, production support, all these things. Again, you are automating their job also. Development plus operations. That's the we are automating the processes related to development, developers, QA, and then operations. So after deployment, whatever you're doing here, scale up, scale down, all this is come under operations. DevOps. So now there is another 10, right? DevSecOps. It says, okay, testers, developers, DevOps engineers, operations teams are all working together. What about security team? Usually in Agile methodology, security team works in a different silo. So once you deploy the code, after deploying the code, you call security people for the security testing. Assume that you deploy the code to the production and then you are calling a security person to do security testing. He or she finds some security issue, right? Because of this issue, right? You may have to roll back your code completely. Or your security team is doing testing, during the SIT or, in pre-prod and things like that. So you are basically involving these people, right, at latter stages. Latter stages in the sense development stage, build stage, testing stage, production stage. So more latter you bring them, more complex, right? More problems you face, correct? So security person says, okay, there is a security, issue here. So roll back everything. Whatever you have done before, right? So you have to roll back, it's a roll back everything. And that's a sudden surprise for you. So DevSecOps says, instead of involving these processes, security things at the end, at latter stages, why can't you bring them, right, at early stages itself? That means at the time of development itself, you start your security testing. Here, at the time of build, you start your security testing. So once the build is done, compile is done, we check if there is any, if you are using proper licenses, for example, if there is any security issues in your code. At the time of build itself, we do security testing. Then we deploy the code to the test environment, right? Here we do the security testing. Then we do security testing, in the production. So since you are involving security things at the beginning stages, if there's any problem, you can identify the issue here itself, correct? So it's identifying the issue here at latter stage, identifying the issue in the beginning stage has a difference, right? So DevSecOps says it's called as a shift left. Shift left means first stage, second stage, third, fourth, fifth. So instead of identifying it, instead of doing security testing here at latter stages, why can't you start security testing here? So shift left, right, left. So left shift means start something at early stages, beginning itself. So if there is any issue, you can fix the problem at early stages very easily. It's the same thing. Okay, see, we are not replacement for security engineers. No, DevOps engineers are not replacement for security. Security team has their own skills. We don't need to have security, engineers skills. No, what we do, we just bring their process. For example, security engineer comes to you. Hello, DevOps engineer, right? Once the build is done, can you run this command? Can you do this security testing here? And they will give some command and we'll just run that command in Jenkins or somewhere. And he will tell you, okay, you run this command, right? If something is wrong here, don't deploy the code. Don't deploy the code. Stop, fail the build, and then report that issue to the developer. Unless developer fixes that issue, don't deploy his code. So you're not deploying the code. You are acting as kind of a gatekeeper there, right? You're not deploying the code. So again, they come. Once code is deployed to the test environment, can you run this command for me? So we will basically run their tools, commands, their automations, right? We will infuse their automations in our place, and then accordingly we will decide whether to deploy the code or not, and things like that. So DevSecOps, you are bringing the security, right? You're making part of the security checks as part of your DevOps workflow, build and deployment process. So that will help you a lot. It's basically, you are bringing developers, testers, security, operations, everybody together. Everybody is working from the beginning itself. So if there's any problem in the security, development teams, QA teams know at early stages itself, and then they fix the problem, right? There is no last minute surprises here. So everybody is working together. So it's just again kind of a culture, okay, right? Culture means it is up to you whether you follow it or not. If you follow, you get disadvantage. If you don't follow, your wish. So that's about DevSecOps. You should know how to, infuse or how to integrate security things in our DevOps process, DevSecOps. That's all from my side today. Any questions you have? Were you able to follow me, right? Do you understand what these tools are, where we use, how these tools help any company, roles and responsibilities of DevOps engineer? Any questions?
Yes, sir, we are able to understand. I have one doubt. Is Kubernetes is like automating? Is it like a kind of automation in DevOps?
Yes, it's automation. Again, we bring the Kubernetes. Using Kubernetes, we automate all these things. For example, as I said, right, we give 100 servers. If there are like less than 100 servers, it will automatically bring it. Here also we write some YAML code, and then it's again like automation. Yeah, what it's automation tool which automates all these things for us. We run our production applications inside the Kubernetes. That means we run all these containers inside the Kubernetes. Okay. So if you're able to understand 50-60% of it or 70%, I'm fine. Right? If you have any confusions, don't worry. As I said, when I start the tools, I'll explain from very basics. By now you would have understood my explanation skills, right? So it's like complete course in 2 hours, I think. Very difficult for me to make you understand, but yeah, so don't worry. I know how to simplify the concept, you'll understand. So why you have to join Viculty? Just within less than a minute, okay? So Viculty is a training institute name. So as I said, it's a 3 to 4 real-time projects we'll be working on, and then primary experience is 5 years, 17 years experience, and 10 years experience in teaching. Trained more than 15,000 students, online, offline. I do a lot of corporate trainings also. More than maybe around 7,000-8,000 placements. I can also give you 100% placement. We can talk that offline. That means once you complete the course, I'll help you with the resume preparation, your Naukri profile, updates and things like that, and you can start giving interviews on your own. See, I'm not exaggerating here. I can say 90%. But I'm not claiming it. 40 to 50% of my students, they get the job within 1.5 months after completion of the course. Remaining, say, 20-30%, for remaining 20-30% people, it will take 4 months to get the job, because they are busy people, or they are not spending enough time for practice and things like that. Remaining, say, 10-20% of the people, they will never get the job because they are not serious learners. See, our average, I can see 60-70% of my students get placement within 1.5 months or 4 months or whatever. Again, you need to also put your efforts on top of what I teach in classroom, and that's how it works. 100+ hours extensive training it is, right? So that's how you get the placement. And since I've been this industry for last 11 years almost, I also get a lot of clients. A lot of clients come to me for placement. So if I get any such opportunities, I'll also forward those things to you. Not required. If anybody says 100% placement guarantee, so it's not always true. People just use those marketing words and things like that. But I can give you to some extent. I have different ways to place. Okay. You don't need my placement support from my side. In worst case, if you are unable to crack the interview, you come to me. I have different ways to get the placement, and we'll talk that offline. So it's 100+ hours of training, and then all support will be there, interview support and all the stuff. What else you're looking for apart from this?
So when is the next batch starting from?
I'll start next batch maybe from tomorrow itself. Okay, this is a demo, right? After demo, I'll immediately start the classes from tomorrow.
Okay, so
you'll get that message from IHR. Yeah.
Okay. And what would be the timings of the class, the immediate batch?
I'm thinking 7 to 8. 7 to 8.
Evening or morning, sir?
Evening. 7 to 8 or 7:30 to 8.
So we have offline classes also?
Offline, I'm not doing it at the moment, but you can you start with online maybe for 1-2 weeks. After 1-2 weeks, I'll again continue with the offline. For another 1-2 weeks, it will be online mostly. Usually, I take online, offline
Okay,
both at
noted
the
that.
same time, but you start with online now. After 1-2 weeks, I'll start offline also.
Yeah.
Okay, so these are the few things, few unique things that you get here.
Nagesh,
Yes,
sorry, Ishwarav.
that's okay.
See, I have about 15 years of experience in
Mhm.
different technology, legacy systems. So what do you suggest me, like, with the 15
You're
years?
working on you said you're working on security side, right? You're the ready.
No, legacy systems,
What technologies?
mainframe.
Mainframe, what else? Only mainframe?
That's our mainframe.
Mm-hmm. So this is what you have to do. See, once you complete this course, as I said,
Mm-hmm.
you will get the knowledge which is equal to a 3-4 years real-time experience person. So what you can
Okay.
say is, once you complete the course, you can say that, okay, for last 4-5 years, I've been working on DevOps.
Okay.
And previous experience, you can claim on your maybe 2 years on
But
Linux.
how about the salary? Will they accept the same salary that I am getting now? 4 years of DevOps. By the way, forget about that. Like, I just want to know how much that people will pay for 4 years DevOps training.
So this is the thing. Usually, salary tends. You can follow this formula. But in your case, even you claim 4 years relevant experience, they won't consider only your experience as full. They consider full experience because apart from the technology, 15 years experience means you would have gained a lot of other excellences, right? Team
Yeah.
building, management skills, understanding the criticalities, taking ownership. So these skills also matters, right? So even though you say 4-5 years of experience, right, they still consider your full experience, but salary they may pay a little less compared to the 15 years, poor DevOps engineer.
And
So
I
usually in
might
DevOps,
have
this is the
missed.
salary
I
band.
might have
For
missed
example,
how much I will get for 4 years. Can you tell me like how many, how much we can
see this
expect for four
experience.
years?
Yeah. So you can calculate this way. Your experience, okay, into 3.5 or 4. So 4
Okay.
years experience, for example, right? 4 into
Yeah,
3.5,
yeah, yeah.
say 14 lakhs package. Say you have 5 years
Okay.
experience, 5 into 3.5,
Mm-hmm.
right?
Mm-hmm.
Say 17.5 lakhs package.
Okay.
Likewise, you can say, sometimes you'll get your experience into 4 also. 4 years, 4 into 4, 5 years into 4.
Okay.
So,
Uh-huh.
20. So that's a trend, usually.
Mm-hmm.
Up
Okay.
to experience into 3.5 or 4. So that is the.
Okay. Okay. Okay.
In your case, Jonathan, you also mentioned that, something happened here. You said, if I claim, say, 4-5 years relevant experience, will they match my salary? I'll do one thing then.
Yeah.
So you call me after the demo offline, take my number.
Sure. Right.
I'll ask your CTC because I want to know your CTC and things like that. And
Right.
there are different ways to transition your career to DevOps, right?
Right.
In most of the batches, I'll be having people from development, testing, like mainframe is big example, right? Because it's kind of a dying technology. So I would say maybe 10-20% of people are from the mainframe. So I have to check a lot of things. I'll take it offline. Okay, you just call me.
Okay. Can you drop me your number here? Or should I call other girl who is reaching me?
No, that's okay. I'll give my number. I can't write here.
Okay.
1 second. You can note down my number.
Please.
So other people, if you have similar kind of things, a few things we cannot discuss, right here, right? So you just call me 97393 68768. And if you see our faculty, this is the tagline we use: transition your career now. So we are experts in transitioning careers from the other legacy technologies to the DevOps latest. Okay, so this is WhatsApp also. If I don't pick the call, just drop me a message. I'll call you back whenever I get some time. Okay.
Okay.
Other
Okay.
people,
Thank you so much, Anish.
no problem. Any questions you have, others?
Nageswara, what is your duty timings? Suppose let me know your free time, then we will call.
You can call me after 2 p.m. 2 to 7. Usually my classes start from evening 7 o'clock, 7 to 8 one batch, 8 to 9, 9 to 10. 7 to 10, I'll be busy with different batches. The best time is 2 to 7, afternoon 2 to evening 7, or after 10, after 10 p.m. So 10 to maybe I'm available till 12, 1 o'clock.
Yes, got it. Thank you.
Yeah, any other questions, guys? Hope you understand. At least would have got some clarity about what is DevOps tools and things like that. I hope you enjoyed. Any questions you have? Any other confusions?
Certification.
Nothing as of now,
How
sir. I would like
you are
to.
helping on certification? Nageswara.
I'm sorry, I could not hear you.
No, certification. How we are proceeding? Like we may need to take the certification, right?
So
Or
once
you are helping in.
once you complete the course, I'll give you the course completion certificate. Okay, that's one thing.
Okay.
That will help for freshers and few people. And see, I don't recommend you to do certification in DevOps. No, because it's kind of a process, right? So DevOps is not from a particular company, right? Of course, see, if you do certification in AWS, it will come from Amazon. If you do certification on Azure Cloud, it will come from the Microsoft. Who will certify you? Again, there are a lot of companies who give DevOps certifications, but there is no authenticity, right? So there's no authentic body, who can give a certification in DevOps. Instead of doing certification and in DevOps, better you do certification on individual tools. For example, Kubernetes certification. There's something called CKA, Certified Kubernetes Administrator. So I prefer you to do this certification first, then do the certification on some cloud. Okay. And probably these two are enough for you. So don't do certification on DevOps. Instead, do take certification on individually. That's what I recommend.
Yeah, got it. Thank you.
See, I can also give you, DevOps certification. I just open a website, right? I take some fees from you, right? I conduct some exam, and then I'll tell you, okay, you are a certified DevOps engineer. But how, what credibility I have in the market, right? So how I assess you, how popular I am, my company, right, is very important, right? So there are a lot of people who issue certification, but those people are not popular. Even you give their certificate, show their certificate, companies don't value you much. So take the certification on individual tools.
Yes,
Okay.
thank you.
No problem. That's all, guys. Thank you very much. And in case of any other questions, please reach out to me. If something urgent and if I'm not responding, for example, you can get in touch with Ayesha and we'll start the new batch from tomorrow or day after tomorrow. Ayesha will get in touch with you for enrollments and you can start with that. Thank you, everybody. Good night.
Yeah, thank you.
Thank you, sir.
Thank you.